A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend.
Hi everyone, welcome to the video lesson for Thursday, February 18th and Friday, February 19th. Today in class we went over moles and molar mass, but first we started with the warm-up. So today's warm-up was almost entirely answerable from your homework if you had a chance to finish it. A dozen is equal to 12. A gross is a dozen, so 144. A mole was part of your homework, and it was also the song that was playing before class. 6 times 10 to the 23rd. And then the fourth question was straight from your Gizmo Part A. Towards the end, it asks you to calculate the molar mass of FeCl2. So iron 2 chloride, 1 mole of that, is equal to 126.75 grams. Now, I also said in the warm-up, just go ahead and tell me if you didn't get that far. I know that the Gizmo Part A was kind of long, especially for a week where we didn't actually have a Wednesday and a synchronous day. So if you wrote that you didn't get that far in the homework, that was okay as well. Besides the warm-up today, there were no new assignments given out. So your homework this weekend is to finish Gizmo Part A. As long as you got it in the same day it was due, it's not going to be counted as late. And your second attempt for the checkpoint about balancing and reaction types has been unlocked. So if you haven't gotten an A yet, you really need to retake that quiz so you can up that score. Remember, we always take the higher of your scores. And if you don't like your first grade and you're not quite sure what happened, or you took it once and you don't remember how you did or what you got wrong, we can always look up your answers if you come to a student support session. So when you go to your week 3 module, right underneath second class of the week, there's only the one link, student copy of Mol Notes. Go ahead and click on that. It's going to ask if you really want to make a copy of this and put it into your G Drive. Click Make a Copy. And once it loads, make sure you go up here to this little folder. It says Move. And you're going to want to remove that into your chemistry folder, which you should hopefully have somewhere in your Google Drive. Slide 2 has a table of contents. There's 4 different sections here. There are notes about what a mole is, how to find molar mass. There's a link to Part B of our Gizmo. And then next week, we're going to get into the factor label method for conversions. And once again, after each section, I've got some embedded videos. This is actually a particular favorite of mine, embedded on slide 5. I'm actually kind of sad we don't get a chance to watch this in class this year. It's a really good one. It only takes about 3 minutes, and I highly suggest you watch it if you haven't yet. Our notes today started on page 3 of your Google Slides. Your Gizmo Part A, the homework, really focused a lot on copper to begin with and copper atoms. Here I'm going to be focusing on carbon. So if I have a periodic table open, I can look at the average mass of one of any of our elements. In my carbon box, C, number 6, the number below that C is my average atomic mass. So it's 12.011 AMU. I wrote it as 12.01 AMU because whenever you're dealing with mass, I would like you to go ahead and round to 2 decimal places. And AMU stands for atomic mass unit. It's roughly the average mass of one neutron or one proton, although we officially define it as 1/12 of the mass of a carbon-12 isotope. My average oxygen atom, if I look up its molar mass, is listed as 15.999. So if I want to round that to just 2 decimal places, that third decimal being a 9 rounds up the other decimal, which is also a 9. So this actually rounds up to 16.00 AMU. And then one average neon atom is listed as 20.18 AMU. Now, the next line here is not in your notes, and it's not entirely factual, so you can kind of forget about it after this slide. So I have here that one average carbon atom weighs 12.01 AMU, or 1.2 times 10 to the negative 22nd grams. But if I had 10 atoms of carbon, that would weigh 120.1 AMU, or 1.2 times 10 to the negative 21 grams. So I'm already weighing more. I've got more mass. I started with 0.21 zeros and then 1, 2. Now I'm at 0.20 zeros, 1, 2 grams, so I'm getting slightly larger. If I had 1,000,000 carbon atoms, well, that would be 12,010,000 AMU. Or if I tried to measure that on a scale, it would be 0.15 zeros and then 1, 2. So 1.2 times 10 to the negative 16. In part A of our gizmo, you couldn't even put that few atoms onto the scale. You couldn't add or subtract only 1,000,000 atoms. The lowest amount that you could even work with was, I believe, 10 trillion. So 1,000,000 atoms, even though 1,000,000 is a very large number, is almost nothing when I'm talking about atoms. But still, my mass is increasing by quite a lot. So eventually, I can get enough carbon atoms that would weigh 12.01 grams, the same amount in grams as it weighs in AMU. So that magic number of how many carbon atoms do I need? That's 6.022 times 10 to the 23rd atoms. It's 1 mole. So a mole is the number of particles of an element or a compound that weigh the same amount in grams as only one of those particles weighs in AMU. So one carbon atom weighs 12.01 AMU, but once I have 1 mole of carbon atoms, it now weighs 12.01 grams. And particle is just our science way of saying things. It's how many of that type of thing that I have. So here, I was dealing with carbon atoms. A carbon atom was my particle. So 1 mole of carbon particles is 12.01 grams. So for that last fill in the blank on your slide, 1 mole is equal to 6.022 times 10 to the 23rd. Now, in the middle of slide number 4, there's another definition for a mole. A mole is also defined as the number of gas particles in a 22.4 liter container at standard temperature and pressure, so that means 0 degrees Celsius and 1 atmosphere of pressure. That's not the definition we're really using right now, but I just would like you to know they talk a little bit more about it in that video embedded on slide number 5, so I highly encourage you check that out again. So on slide number 6 is molar mass. So molar mass is the mass in grams of 1 mole of an element, compound, or other types of particles. And it is always going to be measured in grams. However, after grams, I would like you to put in parentheses grams divided by mole, or G divided by MOL. That is another way you can see molar mass written. You will see it written in that form a few times. If I'm ever asking you a question and asking you for the molar mass of something, using just grams or grams per mole are both acceptable answers. The grams per mole is more useful when we're working with conversions, which we will be doing soon. Now on that same slide, I have this example equation. You have been balancing equations for a little bit now. When you were balancing equations, you were looking at the number of particles, but your number of coefficients actually refers to how many moles of each substance. You never really have just one carbon atom reacting with one molecule of oxygen to form one molecule of carbon dioxide. You have 1 mole of carbon atoms reacting with 1 mole of oxygen molecules to form 1 mole of carbon dioxide. So we can find our molar masses. If I have just 1 carbon, that means I have 1 mole of carbon atoms. So its mass is 12.01 grams. If I have O2, I have 1 mole of oxygen atom number 1 and 1 mole of oxygen atom number 2. So 1 mole of my first oxygen atom is 16.00 grams. 1 mole of my second oxygen atom is 16.00 grams. So my molar mass of my oxygen molecule is actually 32.00 grams. Now I realize that in your Google slide, you only have the 1 box to fill. You can go ahead and write in 16.00 plus 16.00 equals 32. Or, if you will understand where that 32 came from, then you are more than welcome to just write 32.00 grams. These are your notes. Then, on my product side, I have 1 mole of oxygen atom number 1, 1 mole of carbon atoms, and 1 mole of oxygen atom number 2. So I've got 16 grams from my first oxygen, plus 12.01 grams from my carbon, plus 16.00 grams from oxygen number 2. So altogether, my carbon dioxide's molar mass is 44.01 grams. Now, while you've been balancing reactions, we've been having you count those atoms to make sure you don't create or destroy atoms in your equation. But there's something a little bit bigger going on there. The law of conservation of matter is also known as the law of conservation of mass. When I have a chemical reaction taking place, it's not just the number of atoms that don't change, it's also the mass. You can see here that my total beginning mass is 44.01 grams, and my final mass is 44.01 grams. So I'm conserving my mass in my chemical equation. On our next slide, we have the 3 steps you need in order to solve for molar mass. So step number 1, the first element in your compound, you need to look up its molar mass using the periodic table. Remember, round to 2 decimal places. Then you want to multiply it by how many of that atom you have. So look at your subscript. Then you could kind of put in another rule there, 2b, repeat for all elements in your compound. And then your last step is you add together the masses of all of those elements in the compound. So in class, we had an example. We had C2H4. So the mass of carbon is 12.01. My subscript is a 2, so 2 times 12.01 gave me 24.02. Next, I had hydrogen. So the mass of hydrogen is 1.01 times its subscript of 4 hydrogens gave me 4.04. So when I add 24.02 grams plus 4.04 grams, I get a final molar mass of 28.06 grams per mole. On slide 8, I've given you 4 problems so you can practice solving for molar mass. In class, I gave you guys about 2 to 3 minutes and links to your periodic table So you could take the time and try to solve these questions. If you missed class and haven't had a chance to do so yet, I highly suggest that you pause the video here before you continue to see the solutions. So for H2O, your final answer should have been 18.02 grams. I have two hydrogens with masses of 1.01 grams each for a total of 2.02 grams. And then one oxygen weighing in at 16.00 grams. So if I add those two together, I get 18.02 grams. For sodium chloride, my final mass was 58.44 grams. I have 1 mole of sodium atoms weighing in at 22.99 grams each, and 1 mole of chloride atoms weighing in at 35.45 grams each. So when I add those two numbers together, I get 58.44 grams. My calcium carbonate, the final answer was 100.09 grams. I have 1 mole of calcium atoms weighing in at 40.08 grams. I have 1 mole of carbon atoms weighing in at 12.01 grams. And then I have 3 moles of oxygen atoms, each weighing in at 16 grams for a total of 48.00 grams. So when I add these all up, 40.08 plus 12.01 plus 48.00, you get your final answer of 100.09 grams. And then my last example here was aluminum sulfate. I have 2 moles of aluminum atoms here, each weighing in at 26.98 grams, for a total contribution of 53.96 grams. My aluminum sulfate has 3 sulfates. Each sulfate has 1 sulfur. So I have a total of 3 moles of sulfur atoms, weighing in at 32.07 grams each, for a total contribution of 96.21 grams. And then I have 4 oxygens in each sulfate, and there are 3 sulfates total. So I have a total of 12 moles of oxygen in this compound, each one coming in at 16.00 grams, for its total contribution of 192.00 grams. So when I add these all up, 53.96 plus 96.21 plus 192 grams, I get a grand total of 342.17 grams. Now, if you look at these problems and these solutions very carefully, one of my numbers was off by 1 digit. Someone caught this earlier today. I wonder if you can see it now. It doesn't make a very large difference, but you might notice that you may have gotten a slightly different answer for one of these. Come and see me during office hours and I'll happily show you which one it is, so you don't have to worry too much if you can't find it. On slide 10, I embedded a link to our classwork Gizmo. So go ahead and click on that image. You're going to see that there's a link embedded. Open that up. And hey, look, it's our old friend, the copy document page. So go ahead, make a copy of your document. Once that loads, as you always should do, go to the Move folder and put this into your chemistry folder. And there's another fun thing you can do if you're feeling pretty tech savvy. What I would do is go over here to the Share button. Click on this. You don't need to worry about who it's shared with or your shared settings. Just go right here to Copy Link. Go back to your note slides. Click on this image again. And then if you click right here on that pencil, you can edit the link. Just paste that link you just copied into this box. And now your notes will link to your other classroom. Instead of generating a new copy every time, it'll take you to your personal copy. A nice little way to have your notes easily accessible. So part B of the Gizmo has us solving find the mass of 2 moles of carbon. So you fill the first 2 jars with 2 moles of carbon. Before we can try and solve to find the mass of 2 moles of carbon, what do we need to know about carbon? And it gives us a hint, something we would need to look up on the periodic table. Now, this is one of those questions that's so easy, it actually kind of doubles back over and becomes really hard. You need to know the molar mass for carbon. Once you know the molar mass, you can figure out how much 2 moles of carbon would weigh. So the next thing it asks is to click on Show Molar Mass. I don't think we really need to do, since we've worked with this molar mass so much already this class period, but it lists it here as 12.01 grams per mole. So now we know how much 1 mole of carbon weighs, and we want to find out how much 2 moles of carbon would weigh. So it asks you to show your work. Now, I'm sure that we can all do 2 times 12.01 to find out that it's 24.02 grams. But I'd like to point something out in how I did my work. So we were given the molar mass as grams per mole. I know that the molar mass is 12.01 grams per mole, and then I'm multiplying it by what I have, 2.00 moles. So notice I have divided by moles and multiplied by moles. I have moles on top of a divider and on the bottom. So think about what happens to an x in math class. If you have 1x on top and 2x on the bottom, you know your answer is 1/2. Those two x's cancel each other out. Here, I'm starting with grams divided by mole. I then multiply by moles, so I've got moles on the top and the bottom of a divisor. So they cancel out. All that I'm left with is grams. This is going to be a really big theme for the next few weeks about canceling out units by putting them on top and on the bottom of divisors. Now, I'm pretty confident in our math, but the Gizmo asks us to take the jars of carbon and pour them into the balance, so let's go ahead and do that. And our balance says 24.02 grams, which is exactly what we calculated. Now, I'm not collecting this Gizmo next week. This is going to be our classwork next week. So we're going to be returning to this next Monday and Tuesday. You do not need to finish this for homework. We will do so in class. So that's as far as we got during class today. There are no new assignments this weekend. Just make sure you have all of your previously assigned work in by now. And if you're feeling kind of unsure about Molar Mass, the Silver Apps website does have a Molar Mass practice app that you had to do and get 10 points on in your Gizmo Part A. But I'm also going to post another resource for you. It's a older worksheet that we used to give out for homework. I'm not going to post the answer key because I don't want the answer key out online. But if you come during a student support session, we will have it and we'll be more than happy to go over the solution. So until I see you guys next, stay safe and make good choices, guys. Enjoy the snow.